Hello everyone, this is P. Shilamani here. First of all, I would like to welcome you to my today's session. In this session, we are going to discuss about what do you mean by isomorphic, and followed by we are going to check whether these two adjacency matrices are isomorphic or not. Okay. Before we dive into solving this problem, let me have a quick review about what do you mean by isomorphic. So for isomorphic, we are going to check whether these two given graphs are isomorphic, which means we are going to check whether these two graphs are same in the inside or not, though it is different in the outside. Okay, which means though it is different in the outside, we are going to check whether these two graphs are same or not in the inside. Okay, so if they are same in the inside, then we can say it is isomorphic. That we are going to check. So to check that, we have four conditions. The condition 1, all the vertices should be same in both graph. Condition 2, all the edges also should be same in the both graphs. In condition 3, we are going to check whether both graphs are having same number of degree to all the vertices or not. In condition 4, it is adjacency or not. Okay, that we are going to check. If any two graphs are satisfying these four conditions, then it is called isomorphic. Let me come here. So here we have two adjacency matrices. This is adjacency matrix of G1, this graph 1. This is adjacency matrices for graph 2. We just have made. Okay. So here our task is we have to check whether these two adjacency matrices are isomorphic or not. So to check that, in the previous problem we had graph directly. Okay, if we have graph directly, it's very easy to check the adjacent, to check the isomorphic, right? But instead of giving graph, if adjacency matrix is given, then how to check whether the following two graphs are isomorphic or not? That we are going to discuss in this video. Okay, first, our first task is we need to draw the diagram for the given reference, right? So first, let me draw the, before we are going to draw the diagram, we have to check how many vertices that we are having in both graphs. Let me check. So here V1, V2, V3, V4, V5, V6. V1, V2, V3, V4, V5, V6. So it has in graph 1 it has 6 vertices. Let me come to graph 2. In graph 2 also we have 6 vertices, right? So in both graphs we are having total number of vertices are same, right? So first conditions are satisfied. Let me come to check the second condition. To check the second condition, we need the diagram so that we can easily identify whether total number of edges in both graphs are same or not. Okay. To check that, I am going to draw the diagram. First, let me plot 6 vertices. Vertices 1, 2, 3, 4, 5, 6. After that, we are going to draw the edges. Okay, here is given the adjacent edges. Okay, information is given here. Based on this information, I am going to connect the vertices, right? So V1 is adjacent to V2 and V4, which means there is a line between V1 to V2 and V2 to not. There is a line, which means there is an edge between V1 to V2 and V1 to V4. So here we have V1 to V2 and V1 to V4. We have an edge. Let me come to vertices 2. Here it is contributing an edge from V2 to V1, V2 to V3 and V2 to V6. So from V2 to V1, V2 to V6 and V2 to V3. It is contributing, it is adjacent to these three vertices, right? Let me come to V3. So V3, it is contributing to an edge from V3 to V2. So from V3 to V2, there is an edge. From V3 to V4, there is another edge. So let us come to V4. Okay. In that aspect, you have to complete the diagram. Let me come to diagram. So we have successfully completed the diagram, right? So in the same concept, with the same concept, we are going to draw another diagram for this adjacency matrix, which is graph 2, right? So how many vertices are we having in graph 2? Yeah, here also we are having 6 vertices. Let me plot the 6 vertices first. This is, you just name in the different letters, right? So for graph 1, I have used V, okay, to mention my vertices. In graph 2, I have used U to mention my vertices, right? So here 6 vertices we have in graph 2, and first I'm going to plot the vertices first, V1, V2, V3, V4, V5, V6. Next, I'm going to connect the vertices based on the given information given in the adjacency matrix. So U1, there is an edge between U1 to U2 and U5. So here we have U1, from U1 to U2 and U5. So there are two, U1 is adjacent to U2, U1 is adjacent to U5. Okay, let me come to U2. U2 is adjacent to U1 and U3. Here we have U2. It is U1 and U3, right? So in the same concept, you have to draw all the edges based on the given information in the adjacency matrix. After we complete this drawing diagrams for the given information in the adjacency matrix, let me come to check the last condition. Okay, so far we have checked only one condition in both graphs. Graph 1, this is graph 2. So in both graphs we are having same number of vertices. It is 6. Let me check whether we are having same number of edges or not. So this is edge 1, edge 2, edge 3, edge 4, edge 5, edge 6, edge 7. Let me check how many edges are we having in graph 2. Edge 1, edge 2, edge 3, edge 4, edge 5, edge 6 and edge 7. So look at both graphs, we are having same number of edges too. Okay, let me come to check the third condition. It is whether both graphs are having same number of degrees or not. So it is having degree 2, 3, 2. Degree is nothing but to calculate degree for V1, we have to check how many edges are incident with this vertex, right? So there are 2 edges are incident with this vertex V1. So the number of edges incident with this vertex is called the degree of that particular vertex. So it is 2. In that aspect, we can calculate all other vertices. So 2, 3, then 2, then 3, then 2, then 2. Let me check the degree with the same concept for graph 2. So it is 2, 2, then 3, 2, okay, then 3, sorry, one second, U1, U2, U3, U4. U1 is 2, U3, U2 is 2, U3 is 3, U4 is 2, U5 is 3, U6 is 2. So it is following same number of degree sequence. So we have 2 times 3. Here also we have 2 times 3. Then 4 times 2. Here also we have 4 times 2. So therefore the degree sequence are also same. What is the last condition? We have to check whether it is both graphs are adjacent or not. To check that, there are so many ways. You can easily check by seeing the graph itself. So we have to say 2 different cycles. Okay, both cycle. Okay, if both cycles are same in the both graphs, then it is called adjacency. Okay, let me check. So I'm going to check first. There is a cycle between these 4 vertices, right? So there is a cycle, 4 vertices. There is a cycle in 4 vertices. I have to find another cycle in another vertex, different vertices. So 1, 2, 3, 4, 5. There is another cycle between these 5 vertices. So we have 2 cycles, 2 different cycles. So one cycle between 4 vertices, another cycle between 5 vertices. If we have the same cycle with the same vertices in the another graph, okay, graph 2, then it is adjacency. Let me check whether there is a cycle between 4 vertices and 5 vertices. So 1, 2, 3, 4, 5. So here also we have a cycle between 5 vertices. Let me check whether it is a cycle between 4 vertices or not. So 1, 2, 3, 4, 5. This is another cycle. So it also has 2 different cycles between 4 vertices and 5 vertices. So the same cycle we are following in both graphs. So it is satisfying the adjacency. Okay. So absolutely these 2 matrices are isomorphic. Okay. Thank you so much. I hope you have got a clear idea about how to check whether the following two adjacency matrices are isomorphic or not. So if you have any doubt, you can text me in the comment box. I will help you. Thank you.